Okay. Let me see. Okay, I think we're live. So let's put this away. I just made the thumbnail. Okay, so let's see how long today takes. Yesterday was a bit of a nightmare. I spent way too long on a problem. So let's see if we can do it a bit faster today. But yeah, just here to have fun, right? So let's see, day 8, a 7-segment search. You barely reach the safety of the cave when the whale smashes into the cave mouth, collapsing it. Ah yeah, because yesterday we were chased by a whale that wanted to eat us, and all sorts of tiny crabs in the submarines blew a hole in the ocean floor to send us into caves to save us. So let's see. Sensors indicate another exit to this cave at much greater depth, so you have no choice but to press on. As your submarine slowly makes its way to the cave systems, you notice that the 4-digit 7-segment display in your submarine are malfunctioning. They must have been damaged during the escape. You'll be in a lot of trouble without them, so you better figure out what's wrong. Each digit of the 7-segment display is rendered by turning on or off any of the 7 segments named A to G. So this is like on your alarm clock, right? So let's see. To render a 1, only segments C and F would be turned on, the rest would be off. To render a 7, A, C and F would be turned on, etc. The problem is that the signals which control the segments have been mixed up by each display. Okay, has been messed up on each display. The submarine is still trying to display numbers by producing outputs on signal wires A through G, but those wires are connected to segments randomly. Worse, the wire segment connections are mixed up separately for each 4 digits display. All of the digits within the display use the same connections though. Okay. So you might know that, this is bright, let's turn off this monitor. Let's see. So you might know that the only signal wires B and G are turned on, but that doesn't mean segments B and G are turned on. The only digit that uses 2 segments is 1, so it must mean segments C and F are meant to be on. With just this information you still can't tell which wire BG goes to which segment. For that you need to collect more information. Okay, I think we did this a few years ago, something similar. Not exactly the same, but something similar. But it's been long enough ago that I forgot how it works. Let's see, for each display you'll watch the changing signals for a while. Make a note of all 10 unique signal patterns you see and then write down a single 4-digit output value, your puzzle input. Using the signal patterns you should be able to work out which pattern corresponds to which digit. For example, here is what you might see in a single entry in your notes. The entry is wrapped here with 2 lines, so it fits, okay? In your notes it will all be on a single line, okay? Each entry consists of 10 unique signal patterns, a delimiter, and finally the 4-digit output value. Wait, what? Okay. Within an entry, the same wire segment connections are used, but you don't know what the connections actually are. The unique signal patterns correspond to the 10 different ways the submarine tries to render a digit using the current wire segments, wire/segment connections. Because 7 is the only digit that uses 3 segments, DAB, so this one in the above example means that to render a 7, signal lines D, A and B are on. Because 4 is the only digit that uses 4 segments, EABF means that to render a 4 signal lines E, A and F and B are on, okay? Using this information, you should be able to work out which combination of signal wires corresponds to each of the 10 digits. Then you can decode the 4-digit output value. Unfortunately, in the above example, all of the digits in the output use 5 segments and are more difficult to deduce. Okay. For now, focus on the easy digits. Consider this larger example. Because digits 1, 4, 7 and 8 each use a unique number of segments, you should be able to tell which combination of signals correspond to those digits. Counting only digits and where the output values on each line in the above example, there are 26 instances of digits that use a unique number of segments highlighted above. Wait. Okay, so in the output values, how many times do digits 1, 4, 7 and 8 appear? Okay, so that is easy. But that means part 2 is you should probably decode them. But what I don't understand right now is what these parts at the beginning are, because these are the outputs. But I don't understand how this works, because this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these 10 things, what are these exactly? Let me see. All 10 unique signal patterns. Okay. I understand this part. This is how it is what is outputted. I just don't understand what this is actually. Okay, so what we need to do now is just split all the lines by this character and then find the ones that have these number of segments, right? So 1 it has 2, the 4 had 4, the 7 had 3, and the 8 has 2, 4, 6, 7, and the rest all are, yeah. So we can just count them, group by, take out the ones that we want. Okay. Let's just do part 1 for now and then worry about part 2 later. Okay, so we have 2 lines. Okay. As value tuple. Actually, no, I can just take both of these. Skip. Actually, I can do it like this. Or is this an IONumeral? Okay, so I can do skip 1, take 1, and then do first. So this will return an IONumeral of strings. So yeah, to list. So these are our lines. Then we can split them by space actually. Dot split by space. And now we have a list of lines, yes. And now, hi, finally see your stream live. Well, welcome and glad to have you here. Let me paste the day. We're doing Advent of Code, day 8 today. And this is about decoding a 7-segment display. The first part is not about decoding yet, but we'll get there in part 2, I'm sure of it. So what I've done now is to take these inputs, split them, discard the first part because we don't need them for part 1, then split part 2, and we can do this, select x dot length. And we can actually do this as a select many. So this will return a whole bunch of numbers. Then we group by x to dictionary x dot key. So now we have it processed and counted for by segment. So yeah, this part will be useless in part 2, I'm pretty sure of it, but at least this gives us the answer. So we split the input to lines, then we split, let me just outline this a bit so that it's readable. We skip the first part. We then split by space to get the individual strings, and we select the lengths. Those we group by the actual length, and then we count how many we have. So, and now we do lines.where x dot key. So let's see, hash set int to count is new like this, and we need to get a 1, 4, 7, and 8, and the lengths for those were 2, 3, 4, and 2, 4, 6, 7. So we do to count contains this, and then we do some value. So this should actually be the result here. So we do int result is this, and we do console.writeLine result so we do day 8. Let me see, I've completed this one, but I like watching how other people think to see if I can improve my approach. Yeah, I always do the same. So 421 should be part 1, and that is correct. And now we go on to part 2, which will be the real challenge. And I think this will be to decode the whole thing. But as I said, probably before you joined, I didn't understand the first part of the data. So we need to figure this out, but we'll do that. Through a little deduction, you should now be able to determine the remaining digits. Consider again the first example above. After some careful analysis, the mapping between signal wires and segments only makes sense in the following configuration. Let me see. So CDFEB, okay. So the unique signal pattern would correspond to the following digits. So this would be a 5, okay. Then the 4 digits output value can be decoded. All right, because these are the combinations of wires that make up the... Ah, okay, now I understand. These are just all the 10 combinations that it supports, and this is the actual output. My bad, I don't know why I didn't see that first. Okay, so that's easy. So you actually need to do, because if you take the 7, if you look at the 1 and the 7, there should be a match of 2, like here. So you know, by comparing these two, you know that the D is actually the top one. So then you can move on to the other ones. So if you take a 4, that should have 2 that are not the AB, so you can deduce those 2. It's all just power of deduction. I just have to figure out how to decode that. But that'll be okay. So let's see. Let's just take a notepad here. So it's the best way for me to do this. Like, right, these are the 7 segments. So I'm saying if you have like if this is 1 and this is 7, you can just know that the one character that doesn't match will be the top one, right? So we have 1, 2 would be spaced like this. So 1, 2, and 3 would be this. Actually, you have 4. Oh. Need to align that. Bum, 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 bum. So 5 is the other way around from 2. Oh. And then you have 6. 6. Like this, there. No, not that one. We knew 7. We have 8 above. And then you have 9, which starts off with actually oh, like this, right? So these are the 7 segment displays. So let's see. This one was 2. This one is 5. 2, 4, 5. This one was 4. This one is 5. 2, 4. This one is 6. This one was 3. This one is 7. And this one is also 6. So let's see. There will be a way to go from one to the other. So we already know take 1 and 7, figure out 8. And I think we need to, yeah. So it's normally, I can just copy this one, right? And I should actually use a monospace font. Consolas. Not that great, but it works. So yeah, you can figure out A by comparing 1 and 7. So checking those two will give you A. And we know that these two have A, because we can use a 4 to determine the B and D, but not in which place. I'm just thinking, for like the 5 and the 7 have the top and the bottom, but not this one, not the C. So let's see which ones. Because the 2 also shares 2 of the 3 with the 7. Basically, it's a constraint solver. I'm just thinking if I can code this. Let me see. So I could do because I'm wondering if I can just define all the characters and then keep track of which one it can and can't have, and then figure out which one we haven't done yet. I think it's something like that. So we do A is, and then we would have So let's map this to A is 0, B is C is 2. I could make this bit fields and then I could map them, right? Yeah. D is 4, E is 8, F is 16. I should probably start at 1. $32. 64. So we have an enum, and then I'm thinking like 0 is A or B or C or E or F, G. So that way we could do like a flag enum to configure it all. One is C or F. 2 is A or C or D or E or G. 3 is A or C or D or F, G. C, D, F. 5 is A or B or D or F or G. 6 is A or B or D or E or F. And G. 7 is A or C or F. 8 is all of them. Is A, B, C, D, F, G. Right, so this will be our flag enum, and then we have all the fields. Still not sure how I'm going to do this, but let's start here. So we have public enum 7 segment display. Right, to have our enum here. And now I'm just thinking we could decode this in like parts. So, but we still need to have the mapping because we don't know that yet. Let me see. So what we could do is, so if we have like a character, public class 7, let's just call it display for now. And we have a public 7 segment display info. Let's just call it info like that. Possible. And we have a public known. And we have a public impossible. And let's see if we can build like a constraint solver from this. Okay. So for now, we don't know yet. Public class display panel, and this one would have 4 of these, and we would have a signal. So this would actually be a signal, right? Because the panel will have 4 of these. I'm just wondering if the actual, the second part gives us additional information that we didn't have. Because this is just 4 out of these, so I don't think this has any additional info right now. So we need to do it all based off of this. So yeah. Public enumerable 7 segment display info test. Right, so now we can do we need to have the ones that we can test. And these are all the values that are higher. And now it's actually a combination of flags here. Because I want to isolate these to test. So let's just make this a static read only hash set. And it can just be a list actually. List to test is new of this, and then we can do 0, 1, 2, 3, 4, come on, 5, 6, 7, 8, 9. Well, these are the ones that we want to test for. So we can do for each var x into test. Pom, 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 pom. Yeah, sure. Now we can do if for each var known in known. If not x, I need to remember how to test actually. Pum, 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 pum. It's been too long ago. Let's see. Because it's pum, pum, pum. No, it's a bitwise thing. Letter and letters A. Yeah, okay. A, B, or both. What? Was it this? I can't remember. Set flags. Yeah. You add them, you remove them. Okay. Okay. Not set, so next. Oh yeah. So we need to actually make sure that each one of these are set. Let me check bitwise. Check if all flags set. Okay, you test them against the thing that you, yeah, okay, that was what I was looking for. You test it against what you want to know. So we don't for each those because it's just a flag enum. So we need to make sure that all these are set and X and impossible. None of them may be set. And then we need to know about the possible how that works. So I think in this case we can do yield return X. So let's test this, right? Part 2. And we do known. But then we still have the mapping. Hi Nick, love your content, enjoy seeing your solutions. Well, thank you very much. I don't know if I'm on the right track yet, but yeah, this one will be fun. So let's see, if I want to make sure that we know the 7, the top one is called A, right? So 7 is called A, so we know known as this x.test for each option in. Let's see if this spits out everything with the top bar, right? That should at least get us started. Console.writeLine. Possible with segment A. And now we get option. No, option. Haha, this isn't correct. Right, 0, actually 0, 2, 3, 5, 6, 7. It's actually, it is correct. 2, 4, 6, 8. Yeah. Oh, because actually, is the 7 the only one that doesn't have the top one? Yeah. Oh, the 7 and the 4. Yeah. Ah, okay. So we just learned something as well. So if we know the 1 and the 7, we can figure out there will only be 2 characters that don't have this top bar. That will be the 4, which we can identify, and the 1, which we already could identify. Okay, so that gives us nothing new. Damn it! I thought I had something here. Okay. Let me think. So if I look at the ones that share both this and these two, so from the 7 we can find possible the 0, the 3, the 9, 8. Okay. And we already know the 8, so we don't have to count that one, right? So just from that, we can deduce which 3 other characters can be either a 0, a 3, or a 9. So from that on, we know we have B, E, G. So if we look at those, what do they have in common? The 0 and the 3 only share 1, and the other 2 it doesn't share. And the 9, let me see, the 9 shares a lot with the 3. There's only 1 difference, and the 0 has 2 differences, right? Okay. So if we look at 0, 3, and 9 in isolation, you'll see that 9 to 3 means it has one different one. It doesn't have the B, because if you add the B, you get a 3. From 9 to 0, the D doesn't match and the E doesn't match, right? And if we go 3 to 0, let's see, it will have 3 non-matches. Okay. Is that enough? So I think from the 7 we can figure out these 3, just by looking at how many they don't share with the other ones, right? So the 9 will have 1 and 2 difference. The 3 will have 1 and 3 difference. And the 0 will have 2 and 3 difference. So that's a way to figure it out. Hey Richard, hi, welcome. So we can take, we can already identify 1, 7, 4, and 8 ID. But using 1 and 7, we can figure out segment segment A. Then from 7 we can figure out 0, 3 and 9. By comparing those we can at least figure out which is which. And I think we can then also figure out what they all stand for, right? Because if we look at 0, 3, and 9. I'll figure it out in a bit. I'm just thinking, do I do this by hand or do I write something to let the code actually solve it? Because from here you can then progress to the other parts, but I think we just need to find, to write like a constraint solver. Just thinking how we do that based on this. Because I can tell, well, okay, we know this part for sure, and then it can reduce that. And so I could say like, okay, let's remove the D, and then it will spit out less, but I don't know how to get there yet. So we can do impossible is D, for instance, and then it will strip out all the ones with the ones in the middle. So that will just leave 0 and 7, right? And it stripped out 1 because, yeah. So, okay. So basically we can, if we can figure out what we can and can't have, that works. So I'm just thinking if I can figure out, based on this data, because let's see, where is the... Boom. So we have these strings here, right? Let's take the example one. If we take the example one, a little tougher today. Yeah, but this is fun. I really like this. So we have A means C or F actually in this case, right? And we know B also means C or F. Bum, bum, bum. I'm just thinking, in this case, you should probably write like a function that branches out, takes every option and then figures out what it can or can't be. So let's see. Then we get D, and D becomes A. So if we know this, I enjoyed it. Last couple of days have been quite easy. Yeah, except yesterday was so rough for me because I tried to do something that I really didn't need to do. So I figured out something. I'm actually decoding it by hand right now. Because I can figure out, at least I can target like strings and their candidates. I'm just thinking what would be the best way to go about this. Because if we look at the 4 actually, I didn't even think about that. Like the 4, it also shares these two, but then we have the B and the D. Is there a digit here? Okay, so only between comparing, we can isolate 0, 3 and 9 from this part. Then I can compare it to the 4 and know which one is G. So from here I can take 9 compared to the 4 and you get segment G. Yeah, segment G, because that will be the one that doesn't match there. Because we already know which one is A, we know which ones are these two, we know which ones are these two. So the only one that isn't in there that is known becomes segment G. So then we can decode number 3, because that only leaves segment D. Because we know all the other ones. Hey Z, welcome. Thanks for hanging out. So by now, if we do this, we have 3 of the 7 segments decoded. So I wonder, from that we have D, G, and A. So actually the 5 and the 6 share everything but 1. But that's the same for 9, but it won't have this one that we know it has. So I think from isolating C and F before, we can see which one matches like based on 1 but doesn't have one or of these two. But it has this one, and this one. But you also have like the 2. No, okay, we can't do that because the 2 is just the same except opposite. It's like a bit of Sudoku like this. Let me think. Is there a way to deduce more? Because we have G, we have D, and we have A. So we have the 3 verticals in the horizontal bars, we have them mapped. Oh, we can then go back to B, yes. So now we can go back to 4 and know segment B. Because we mapped segment D, so that leaves us segment B. So now we have segment B as well. I think I need to start coding this and see where we go. Let's see if I can actually do what I say here. So let's just take this input string and see if we can decode it. So string signals is split by space. Okay. Actually, we can do it to a dictionary. Okay, it doesn't matter. Should probably just have like a constructor here. String public 7-segment display string signal. So let's do public string signal. And I wonder if I need to put them all together just because they need to know their full range. So select. Right, so now we have 10 of these classes and we don't know anything yet. So what we can do here is switch, so int length, signal.length, switch length, case 2, don't need these, break. So we know that known is, and this becomes, actually this is 1. Right? Let's see. I have a bad brain day. I had 3 fun rounds of debugging and resolving before I realized I had mapped the letters inversely. Oops. My solution is not very nice or efficient, but it worked. Yeah. I'm not sure this is the best way to solve it, but I'm having fun, so let's see where it takes me. 3. Oh man. Case 3. And we didn't known is actually I can't type today. Great. And actually the inverse, I don't know if I need to do this. Let me think. Because but it's actually the letter mapping that we need to work out here. So but let's just continue for now and have at least these mappings done. Case 4 known 4. Come on. 8. We should probably... What was removing them again? I need to... Let me just hit the debugger and test it out, because I can't remember. Let me see. Quick watch. 8. So this is all flag set. Come on. I need to remember the bitwise operations. I don't do them often enough. Bitwise, remove multiple flags. N is daughter mask, okay. Let's see, if you want to do business and operation, bitwise not inverts every bit. Yeah, that's kind of what I want. Do I want to? No. So let's see, it was and then still, okay. Because this was C and F removed, right? Okay, so yeah, that's what I needed, okay. So in this case, we know impossible is, right? And we can just do like this. I wonder if I can do it here, or if that would flip the other stuff as well. Let me just check quickly. So we have 7 segment display. If I have none and dot 1. Okay, that was useful. 7 segment display info dot none, so nothing is set, and tilde that dot 1. Oh man. 1 reevaluate. Okay, so that does nothing if nothing is set, so that is fine. Great. So I can just leave it, let's see, leave it here below. So if known is set, it will make the other ones impossible right at the start, but do we really know that? That's not always the case. So I still need to do it just for this one. Or I could call it like exact, but yeah, this should work. So for each one of these, if I do then do test, it will give us the exact output, I think. So I can do for each var signal var x in signals console.writeLine. So you do exit signal. Yeah, I can just do this. Let's see, and then we do for each var x. Okay, and then we can do this. So let's run this. This should at least map like those. Okay, so here we have 8. This one is all unmapped. 7, 4, and 1. Okay, so far this works. And now I need to use that in conjunction. I should probably set up the other ones as well to reduce the options here. So let's see. We had this one was 2. We have the 5s that are a few. The 6s. Oh, this looks freaky, this 9. I think, do I have an extra space here? No. I should just shift these over. Okay. Pum, pum, pum. So for the 6 and the 9, we actually know this one. Dun, 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 dun. I should actually see which are both set. Ah, thank you. Yeah, I muted the mic, so I hope you didn't hear me sneezing. So yeah, if we have case 6, known becomes, and actually we should, I wonder if I can bitwise the ones that are set, right? So I can do so we can do 6 and 9. Because this one should produce the union of those two, right? I just want to... As I said, I really love bitwise stuff, but it takes me a while to remember everything again. So 6 and 9 has 5 in common. Is that correct? So the top bar, the left bar, the middle bar, the right bar. Yeah, okay. So that's cool. So that actually works. So this produces the ones that they have in common. So these are the known ones. And then we have to actually get the ones that don't match. I like my final refactored solution, but I had 2 typos earlier that meant I wasted on a long... Ah, that sucks. So we know possible would actually be... let's see. Because we need to do the ones that are removed from here and add the inverse as well. I think this is how it works. So this should produce a 2 that we don't know. I want to test this before I move on. Quick watch. So let me just do this first. So this one gives E, right? And if I do this, that would give C. And if I go back, let me just quick watch this right here. It should give us those 2 actually, C and E. Right, cool. I'm glad I remembered all of this correctly. Okay. So this is dope. I really like this. This is when I'm having fun, right? Working out stuff like this. So and then we have case 5, which is just more. And we have default, throw, new application exception, actually not supported exception. We don't support segments with signals. And this will be length. right? And we can probably also set the impossible here for the ones that are not set, but that would be... I don't think there is much there. So yeah, let's not do that right now. 5, this becomes 2. Come on. 2. And 3. Let me see, 2, 3. The mangled 5 here. 2, 3, and 5. This becomes true. This is annoying because I probably need to put these in a list and then just thinking how annoying this is. Because you need to have all of them mapped. So for 2 combinations, this will become large. I'm just thinking if there's a better way to do this. So let's see. Okay. We do known is options. Oh, sorry. Sorry for that. Didn't feel that one coming. So here we do known is options 0. Known n is like that. Let's see, if known come on. Let's just make sure to check this, and this would also be like okay, and this one needs to be, I need to be for actually for each of them, for each var opt in options. Boom. And boom. And we need to do possible. Yeah, we need to test them if opt equals sub opt continue. So we need to test each one against each one of them, and then we do possible, come on, possible and then we do opt and not sub opt. Okay. let me test this here. Okay. And also, come on, I need to write this differently. It's good that I catch it there. What did I break? Feels like I broke something. Let's see. Like this. So I can test that there. Why does it complain here now? Because I didn't put... This is something that's pretty strange. In C# you don't have to put the brackets for a case statement, but if you don't do it, it doesn't get an isolated scope. So I can't do another options within the case statement because there were no accolades surrounding it. So it's yeah, it's not its own scope like that. So I'm just putting this here to test if my code here works, to compare what it did to possible compared to what this would do. Because the options here are written out, and here I can't actually do that because it's just too much and I don't want to. Right, this needs to be changed to commas. Let's see. So possible is C or E. C or E. So yeah, this logic works, which is dope. Because in this case I kind of like to have it just written out because it's very basic, but it's good to know both ways and to test it. So yeah, that's all tested, that should be fine. 2, 3, 5, this is also good. Okay. Let's just run it and see what it spits out. Boom. Okay, I'll probably change something somewhere. Okay, so just by putting in this stuff, we have this one is mapped to 8, 2, 3, 5, 6, 8, 9. Okay, is that true? Is that true though? Okay, because it put all the constraints in a bag, so it gives you more than you want to, right? Because this, these 6 segment ones, signal ones. Let's see. I finally refactored my solution, but had 2 typos early on. That meant I wasted a very long time. Ah, that sucks. Speaking of a long time, I've already been streaming for over an hour. So yeah, I'm having fun, but not even close to the solution yet. Well, I am close, but not the way I'm doing it right now. So by just looking at all the options, it gives us more than we want, right? So we have I'm just thinking, for 6, it has these ones, known and possible, and we should then exclude what is impossible, right? So in this case, impossible is known. Wait, let's see. This becomes known and possible. So everything that's not either known or possible, it should be removed. For these options. And this check can also be removed because it's fine. Curious to see what, if anything is impossible for these and if it filters further, right? Impossible is 8. Right. This needs to be okay. I wrote this one wrong, but that is fine. In this case, nothing's impossible. In this case, is also nothing possible. So this is 5. Oh yeah, with the other two, yeah. Okay, so based on just the segments, we can't reduce it further. But we actually know which ones are impossible. But those are actually result sets. So yeah, we have based on segments, right? We have a solver that can give you information what should be possible. But now we need to work it out further. And I actually need to make sure that some outputs are explicitly forbidden. Actually we can change the to test, because this is our full range and we don't care about other ones, right? So we have list to test. Let me see. Yeah, let me just do it like this for now. And remove these. And here I can do to test that add not known. Well, in this case, it's just known. We already had it here, right? To test add range. Like this. So now at least it will limit it down to what we know. And actually now we need to have the overarching stuff that I started here, right? So you can take the signal of A and B and figure out stuff. Okay. Bum, bum, bum. Bum, 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 bum. So we'll have a dictionary car. Or actually, we can do like this. Mapping is new blah. Let's see. I actually kind of want to go back to how I solved a problem like this a few years ago, but I'll just keep going for now. So we have for action signals, we have for our options is x.test. We probably get possible answers. That sounds better. Options. We can say if options. This is we need to list this because it's an IEnumerable, so we don't know how long it will be. If options.length count is 1, bingo. Else we can do this. Right. Okay. So now we can do mapped.add options 0. X because it's actually a display. Right, so if we have them here. So after we've done that, we can go, okay, now solve segments. So we take mapped dot, no. One signal to char array. One char is this for 7 chars equals this for 7. And now we can do mapping.add segment A, comma A. Right. Let me just see if this works. Okay. So 1 is actually AB. The 7 is ABD. So segment A is D. So now we add our mapping here. Okay. Okay. So that was the first step. Let's see. Now we need to get all the pom 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 pom. So now we get, and we probably should remove the ones that we have not solved yet, that we have solved actually. So let's see, do a list to solve like this. Okay, so now we can do to solve dot where x x dot signal let me think. So we have 7 chars. And then we do x.signal that contains y. Dot length actually. Is this correct? So this will be var 039. Okay. Console, that right line can do dates for 9. I actually don't want to print them out, I'll just inspect them here. Oh, these are 6? Wait a second. Let's see. 2 would not be possible here, but 3 and 5 would. Okay. There are still multiple. Oh yeah, I would need to figure out the cross connection between those, right? Let me think. Three. 9, 7. Wait, let me check. Because 7 was ABD. Right? ABD. So this one doesn't have A. What the? Wait. Let me see. To solve. So we have to solve signal. What am I doing wrong here? These are DAB. And this tests if it has let me see. Why am I thinking about this wrong? Because I check if, for each character, I check if they have it. So let's see. Seven chars, select. Okay. Ah, I need to do where, right? Okay. That was stupid. Set next statement. Okay. Okay, I thought I was going crazy here. This okay. 2, 3, 5. 6, 9. 6, 9. Ah, this is cool. Yeah, cool. So this one matches the 3. And I wonder, because the 6, did I map the 6 wrong? Because the 6 is missing 1. The 6 can't match. Ah, but that one matches the, that one is something that could be a 9. And the other one could be a 9, okay. So the funny thing is, why doesn't 0 match? How many characters have 0? It's 2, 4, 6. Oh, I didn't add. I'm just stupid. Okay. Because this one is actually also 3 options. So I can just copy this whole thing. I actually like this as a test, so I'll just leave it here. And just change it to this one, and this one becomes 0, 6, 9. So 235 069 069. So this is cool because the one that here that said 235, we now know that this is the this is the 3, right? So we do for each var x in 039 if x dot possible three. Now we need to do this, right? Now we do mapped dot add 3 comma x. And we do to solve dot remove x. I did that wrong. Ah, yeah, I need to do the to test one. Ah, I just need to do, yeah, come on, to test. And that's private, so I can't access it. Let's make this public. If x.toTest contains 3, let's try it like this. No, we can actually break. Cool. So now we have an additional one mapped. Okay. What we need to do now is else, so we don't break. We need to x dot to test dot remove, and this one becomes six, right? Actually, we should define this as these are the valid options for this one. For valid options is we have option dot 0, 3, 9. And we can do for each var x in to test. No. We can do it like this so that we can modify it. If not contains x at to test. Come on. this is another sub. And in X of the test contains Y put to test. No, X of to test. Dot remove Y. So this strips all the non-options there, and actually we can remove those because we already know that one, and I think we already figured out how we could isolate the other two as well, because I said when I compare 9 to 3, only one will not match, right? So what I can do is so we actually don't need to do this, we can just break. And this was all for nothing, but that doesn't matter. So now we can do so we can remove that one, and for the other two we can test this loop again. And we can compare them. Let's see, 7 signal display. So we do this, 3, no. Right, and do it like that. And then I can compare this one. So we do x.signal to char array dot accept 3 dot signal dot to char array. Let's see. Ah. So this one is 1 and the other should be 2, I think, right? Yeah. So 9 compared to 3 should be 1, and 0 compared to 3. And 0 compared to 3 should be 3. I wonder. Did I get that wrong? Let's see. We found 3, right? Did I say that correctly? Yeah, because based on the stats, that one could only be 3, if that's correct. So the other two must have a different number. So if I compare 3 to 0, it doesn't match the left line, and it doesn't match this line, and it doesn't match this line. So this should have 3 differences. Yeah. But one of them won't show, right? Let me check. If I reverse these, Okay. So you should combine those two. Right, okay. Isn't there like an outer? No. Let's see. Because there is you need like an except that works both ways, or just do it both ways. But I thought there was actually a function for that. Let's see. Does it intersect? Come on. Right. So they share 4. And yeah. So one should match 4 and the other one should match 5, I think. No. 3 and 4. Boom, boom, boom. The first one is 5, so it only misses 1. C, E, F, B, A, D. And the other one does 4. I wonder. I wonder if this is correct then. So let me just put this here. And 3. So this one doesn't have the F. Let's see, and this has A, B, C, D, right? A, B, C, D. A, B, C, D. So this one is missing on the other side, it's E and G, so that's 3. Right, okay. So I still need to do the except, but then both ways. Okay. Let's just make a string, an extension, public static int mismatch count. This string input string other. And then we do input to char array except input no other to char array count plus the inverse of that. So let's see, that should give us int non-match is x.signal mismatch count for 3.signal. Okay. Need to solve that, close that with a dot comma. Non-match is 1. This one should be 3. Okay, finally. Man. So, switch. Non-match. Case 1. Case 3. 9. 0. Okay, so now we can say boom, 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 boom. 9. Let's see. Zero. Okay, so after that is done, we can compare 9 to 4. So we take mapped signal accept mapped 4 signal and we do char segment G is this, and now we do let's see, where did we put those? Because I added segment A somewhere, right? Okay, that's mapping. Okay. We do mapping dot add. This will be G. Actually no, segment G, G, like that. Okay. Let's run this. So just to make sure that this only produces one result, not that I made a mistake. It produced 2, that's not good. But we already know the other one. Because the mapping we had for D, so we can remove also that accept mapping haha. I need the inverse of that actually. I already have it here, so I can actually do that. Actually, this should be dot single so that it throws an error if it's not as we expected. Set next statement. Okay, so segment G is C. So we're getting there. Now we can go to the 3. We can remove all those. Yep, that's true. So we do char segment D. This becomes 7.signal. No, we take actually 4, right? Not 3. Except 7 and segment G. So gem and segment G is F. Okay, so we have that as well. And now we can go to 4 again, because we figured out segment D. And we can take out these two and have segment B. So we can say segment B is mapped, and we take 4. Remove 1. And then we remove segment D and we save B. Okay, right. So we have segment B. Okay. Okay, so we now have 4 out of the 7 segments mapped. Now we need to convert this into So let me see. So now we can go for each var x in to solve. And we can add to the known stuff here, right? So now we can go for each var key in mapping dot keys. If x at signal contains key, and x dot known and and known. Well, going to get off. Catch you later. Yeah, sorry, man. It's been a very long stream. It's I'm having fun though, but it's not a fast solution at all. So thanks for sticking by, and I hope you still enjoyed it a bit. So thanks for stopping by, Richard. Let's see. So we need to test if it's not there, and if it's not there, we do x.known, and we add known. Okay, so now let's do console right line. Enjoyed it. Well, that's good to hear. Right line, and we have so x.signal, and then we do the options. Okay, let's see what we get if we run this, and I also need to test if this syntax is correct. So known is ADG, known as A. Let me just quick watch this to inline test if it's what I expect. So this is A. Okay, yeah, that works. Here, that's cool. So this is ADG, and we now add B. ADG, so this becomes ABDG. Cool. So now we know another one. So I wonder if this limits the scope, right? So let's see what it spit out now. Reset. Okay, is this? One, two, three, 4, 5, 6, 7, 8, 9. Wait, what? Let me just do another right line here, just to make sure. Dun, dun, dun. Because it first will write out all the mappings right, and then it will do a space. So there will be 3 that it still needs to map. So this one, it already resulted in 5, so we mapped the 5, which is cool. And this one will have 2 options, but we have to compare against what we know already. So let's see. This is funny. Known. Actually, we can do if our options is this. If options count I need to list. Else we write this out. Console right line. We mapped. Okay. So that makes that signal. We already have that above, right? And this will be options 0. Okay, so now we can add mapped. This will become options 0. X. Dun, dun, dun. And we can do to solve that remove X. We need to make sure that we do this into array to create a copy that we can modify. Otherwise, we have to keep a temporary array to delete it while enumerating. So let's see. We had a spacer here, and now I can do for each. X, so we can do x.signal. Oh, this is the key entry.signal. Yeah. Let's see what this spits out now. So we have the first stop, then we have 1, 2, 3, 4, 5, 6, 7 of them mapped. Wait, what? 2, 4, 6, 7. How come there are still 2 here? Oh yeah, 10, right? 10. My bad. And now we can do power of deduction, right? Because we have the 9 here, so this becomes 6. And we have the 5 and the 3 mapped, so this becomes 2. Man, this is cool. We solved it. Took forever, but we solved it. I'm not sure if we actually mapped all the segments right now. Let me see if I still need to do that. Adding all of the output values in this large sample. Ah, okay, cool. So actually we don't need to do that. Just deducing which is enough. Okay. So I will do this loop twice. And I'll actually do while to solve that count larger than 0. Int sanity is 100 and sanity larger equals 0. Okay, sanity check in there. So what we do here now is if mapped contains key option, we remove this option. X to test.remove option. Else if x.toTest.count is 1, so that. Let's see. And we did it. Whew! That was a a long one, but it's cool and it works. Ah. Okay. 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 So after we did that, what we now need to do is convert, make a dictionary lookup for the values. So I need to turn this into a function. Put all of this here. Okay, so let me make a public class panel. Right. This is the panel. Public panel string input. So I'll put all this later. So now we have a public string signal. We already have that. Just the final values to work out on. Yeah. So now I just need to actually make something that creates a mapping out of all the signals and then decodes the second part of the values. So yeah, that should be fine. I'm just coding that up now. So we have a public string signals, and we have a public string display, and this is actually I should, oh. This could be a dictionary string to 7-segment display info. So this is the mapping that we will have in the end. These are the 4 digits that we want to display, and then we do a public int display value, which will be, I took a very different route to here. Yeah, cool. After I'm done, I want to hear all about it actually. I'm just wanting to get this done now. So we do I could make it to support multiple, but I'm just going to hard code it now, because I could loop like from the end to the front and then times 10 the answer, but yeah. So we can do public int get value 7-segment display. Let's see, digit position, switch digit, case 1, val is 0, two, 3, 4, 5, 6, 7, 8, 9, 0, which is also default. All right. 9. And then we do val times pum, 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 pum. Let's see, it's 0, I smaller than position. Just gonna do it like that. It's fine. It's just left to right, so I actually need to do 3 minus. Yeah, like that. Okay, and then we need to return val. So then we do get value signals display. I should probably do this in a loop or something, but I'm getting tired and I just want it to be finished now. Let's see, get value signals display of that, comma 0. I'm just gonna put this 4 times. Normally I wouldn't do this, but I just want to move on and get the answer. And God forbid that I screwed something up and I have to debug as well. So, because it's by now it's been how long? Over 2 hours, man. Let's see. So I have that. So now I just need to do input. So I do var. I can do string signals, string display. Parsed is input that split by as value tuple, but I also need to and now I can just do display, come on, display is parse that display that split space. And in this case, displays will be, my naming is horrible. This will be parse that signals that split, right? And now we have that, and after that is done, we can set up the signals mapping. Let's see. Now I can do maps.select x dot value dot signal x dot key. Let's see. Oh, that is horrible with the feedback loop. Let me see. Do you hear me? Okay. I'm not sure how long this one will keep going, but I put on an external power supply on the receiver. Let's see. Okay, so this one also gave out and I use another power supply. But if I use one connected to the PC, it gives that beeping noise, so it should be okay now. They're both powered right now. But yeah, I officially wore out my battery, so sorry for that. Let's see, we were ordering, and probably to array. Let me see. And then this to array, right? Okay. Okay, so this one is sorted, and now I also need to do the same actually for these. And in this case, 7-segment display. Yeah, I can just do that here on the signal. So I do signal is to car array, sort, order by. To array. Wondered when you would notice the ordering. Ah, okay. Yeah, pretty, well, I don't know. Fast enough. Okay, so this would fix that, right? Okay, so display value 5353. Is that correct? Yes. Oh my god. We are getting somewhere. Whew. Okay, var inputs is input dot two lines. Okay. It reconnected. Okay. Now everything is misbehaving. So let's see. Int, and now let's do long total is 0, 0L. And you do for each string input in inputs. Total plus equals new 7-segment display panel input dot display value. Total. This will spam a lot of data. Did we get an error? No, we did it. Okay. We did it! Woohoo! Man, it feels good to get it like after 2.5 hours. So yeah, that was cool. And I'm really curious to see how other people solve it. Probably very simple or something, but I really like what I built, even though it's kind of a monster, but yeah, it works and I had fun yet again. So yeah. So if you want to share your solution or talk about it, please do. I'm very curious to hear what you did. Thank you. I'm glad you like it. My coffee is cold by now and I barely drank from it, but yeah, it always feels good to solve these challenges. Oh man, I really wonder how long other people did, because yeah, this took me such a long time. And I think there's a better way to like have it more constraint based, to solve it constraint based, but yeah, I worked out in my head how I could do all of this, and from there the code did enough. I worked on the patterns rather than the individual segments. Okay, how do you mean? Do you have a gist or something that you want to share that we can look at together? I always like to do that. Oh man. Because this was also like, I really had fun doing this. Writing all the bitwise stuff and the flag enums, and writing the solvers with like the known and impossible things to reduce the constraint, to reduce all the parts. Yeah. I posted the link. But links don't get sent them. I don't know if there's a way for me to... YouTube swallows links, actually. Let me see. I don't know if you have Telegram. This is my Telegram. You can send it to me there and I'll open it. But any links that get sent through YouTube, if you're not a moderator or a channel owner, anything that has a link just never shows up. So yeah, and that's for live chat and comments. So if you ever want to share a link on chat, you have to be either a moderator or the streamer yourself. That's a restriction, sadly. Let's see. Okay, if you don't have it, it's also not a problem. It's getting very late here, so I should probably stop streaming by now as well. I'm just happy that that this all worked. Like my whole... it often happens that you like come up with an idea and you're not sure if it works. You try to build it in your head and you're like, yeah, this might work. And yeah, I like what I did here. Don't have Telegram. Yeah, okay, I'm sorry, mate. Let me see. I also have a Discord that I barely use, but it's useful to get in touch with me. So, let me see. This is my Discord. I can just go GitHub. Yeah. GitHub. Let me see if I change this. Yeah. There you go. Okay. Let's see. Solutions. 2000, day 8. Okay. Let's see what you did here. And for the people that might be following along, here's the link. Bum, 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 bum. You use the new record syntax for C#8, is that right? Nice. Put in get for this display signal patterns. You're right. You isolate these four. Then you clean them up, okay? Wait, let me see. So by targeting 6, you have, let's see. Six was 0, 6, and 9, right? So what do you do here? Where is patterns defined? Let me see, is new string 10. Okay. For each string, if it all set pattern number, single pattern number. I don't understand this part. Can you elaborate maybe? Patterns 4. Let me see, where's patterns defined here? So declare a new string here. So you're looking at the 4th index of a So 9 has all segments of 4. Let me see. Which means you say 9 has all segments of 4. Yep. But how do you know which one is... because this was already mapped here, right? Set pattern number. Yeah, okay. But aren't there... Okay. Okay, I missed that actually. Well, 8 also has all patterns of 4, but it doesn't have just 6. So yeah. Yeah, the Wisen 4 has to be yeah. I got you. Yeah, I did my own thing here where I compared it to 3. But yeah. So you found a way to get 4 based out of but wait. Yeah, so you get 9 because you already knew 4. And I did it from the deduction based on the 7, right? Yeah. Okay. Yeah, that's nice. So you have a one-on-one way without having to know anything else to find to find a 9. That's a good one. Because, yeah. But isn't there... Yeah, but the 5 doesn't fit in those... Yeah, so for all the ones that have 6 digits, 6 segments, like 6, 9 and 0, the only one that matches with 4. Yeah, good one. Let's see. Okay, so you found a way to map the 6 here as well. Okay. This is a clever way to approach it. And it looks a lot cleaner than everything that I did. So if you do these, then you're left with just these. Yeah, this is a smart approach. So there's just 3, 5 and 2 left, and they... Yeah, okay. And this is a really smart way to approach the problem. How long did it take you to figure that out? Because I looked at it and I didn't see this pattern. It's like I found a way to deduce most of it, and then based off all the other pattern matching, that's the refactive pretty version. Yeah. Well, it's still really nice. I feel like my solution is a big monster compared to this, because this feels even elegant, you know? Yeah, because this just attacks like the problem. Yeah, it's nice. Still happy with what I built, but it's cool to see an elegant solution like that. Because here there's so much... There's very similar logic in here. And I probably should have saved everything as a char array, but bit of time to get the order right. Yeah. It's a nice way to actually attack the problem. Okay. Let's just do that some other time. I'm going to call it. Let's see. I've seen an even more elegant one than this, which is completely linear. Okay, cool. I'm going to watch a few videos of how other people tackle this, I think. But yeah, this looks very clean. Thank you for sharing that. It's a nice way to end the stream. So I want to thank everybody for watching and staying with me, especially for 2 hours and 45 minutes. It's been a long one, but yeah, I had a lot of fun building this one. So thank you everybody, and see you tomorrow maybe. Bye bye.